Welcome to the Unit 6, Day 6 notes. Go ahead, pause the video, work out these warm-up questions quick, unpause and see how you did. So when it says about the origin, we are rotating about the origin. That just means that we are moving around the origin. So around the origin, which is 0, 0. So that is essentially like our pivot point, if you will. And it says, do rotations always have to happen around the origin? No, they do not. Quite often in this class they will, but they could happen around any point anywhere in existence. What's the difference between image and pre-image? Well, pre-image, the prefix pre, means before. So our pre-image is before, or what we start with, and the image is what we end up with after. I like to think of it as the before picture, then some sort of magic happens and you get the after picture, just like the miracle weight loss commercials you see online or on TV every now and again. All right, we've got a couple of vocab terms to add in real quick. A composition of transformation just means that we have multiple transformations happening in a row. We've technically already done a few compositions of transformations when we did the translations and then we did another translation. That was a composition of transformations. A glide reflection is a fancy name just to make you have to remember extra vocab terms for I'm not really entirely sure what reason. But this just means glide is like slide. It is a translation, then a reflection. Okay, you move something over and then you flip it over. All right, and now we're just going to basically jump in and practice these. So it says find the image of triangle ABC after the glide reflection. For all of these, you are going to have two things drawn. Like I give you this, you draw what happens after the translation and what happens after the reflection. So if I want to translate left 10, that's all that says. Okay, I'm going to count left to 10 spots. So A prime would be right there, B prime would be right there, and C prime would be right there. I did that very, very quickly. All right, so the work that I should be showing off to the side is just A to A prime. That's going to be, well, A was 2 minus 10, and then the Y was 4. Right, and then B goes to B prime, which B was at 6, so 6 minus 10, 6. And then C would go to C prime, 8 minus 10, and then 1 becomes -2, 1. All right, after you do that first transformation, cross it off. I don't want you to accidentally do it twice. I've seen that happen way too many times. Okay, and then it says reflect in the x-axis. That's the same thing as y equals 0. Okay, this thing right here. We are not reflecting this thing. We are reflecting A prime, B prime, C prime. So C prime is the closest. It was 1 above. So C double prime will be 1 below. If I wanted to go to A prime next, that's 4 above. So I go 4 below for A double prime, and B prime was 6 above, so B double prime is going to be 6 below. All right, the x values did not change. This is my final answer, and I'm done. This is a composition of isometric transformations is going to be isometric. Okay, if you take something, push it across the room, and then flip it over, it's the same thing you started with. Okay, it's just in a different orientation, in a different location. So it says find the image of segment RS after the composition. So first it says reflect in the y-axis. The y-axis is x equals 0. All right, that's this thing right here. If I want to reflect it across that, R was 1 spot to the right, so R prime is 1 spot to the left. S is 5 spots to the right, so 5 spots to the left for S prime. Cross off the reflection. Now I move on to the rotation. It says rotate 90 degrees counterclockwise. Counterclockwise is going that direction. So I'm going to, remember, have a piece of paper off on the side. I can write some things down. And hold the iPad in both hands. Right hand on the right, left hand on the left, obviously. If I'm going counterclockwise, it means I'm going to pick up my right hand to go 90 degrees. I just turn so my right hand is on top. I'm looking at where R prime is and S prime. If this piece, which was the y-axis, the way I turned my iPad is now my x-axis, and that is now my y-axis. So I would have had to count right 3 and down 1. So I would write that down on my piece of paper. I would write 3, comma, negative 1. And then for S, I would write 6, comma, negative 5. So I said 3, comma, negative 1. That's going to be R double prime. And then I said 6, comma, negative 5 for S double prime. We get that piece right there. If you were to use the distance formula, you can verify that R to S is the same distance as R prime to S prime. Doesn't maybe look like it, but the slope has changed a little bit. So it might make it look like one's longer than the other, but they are in fact congruent. All right, and then these next couple I enjoy. I think they're kind of fun. It says reflect segment KM over line M and then line N. So you're doing back-to-back reflections. All right, so M, big M, was one spot to the left of little m. So M prime is one spot to the right of little m. Make sure you're acknowledging which line you are supposed to flip over first. Because I could give you the exact same problem, say reflect over line N and then line M. Well, then you'd have to reflect over here to get M prime. So make sure you're just paying close attention to those details. All right, K is 1, 2, 3, 4 spots to the left of line M. So 1, 2, 3, 4 spots to the right of RM is K prime. I have done the reflection over line M, so I'm going to cross it off. Since I'm on my iPad, I'm going to use different colors. If I'm going to go across line N next, I'm using just this red M prime K prime or K prime M prime. K prime's one spot to the right, so K double prime will be one spot to the left because we have to go across that line. M prime is 2 spots to the left, so that is 2 spots to the right for M double prime. So I get my final answer just like that. Now, there are a few things that we might be able to notice. It says observations on our next slide. The first observation is going to be one thing I already said. Okay, any composition of isometric transformations is isometric. I said that already. So remember all of those words, what they mean. Composition just means you're doing more than one transformation in a row. Isometric means what you started with and what you ended with are the exact same size, exact same shape. All the corresponding sides are congruent. All the corresponding angles are congruent. Transformation, we have the translation, the rotations, and reflections. All right. The second one, which you probably didn't notice, maybe you did, and if you did, good for you. It says in a double reflection, over parallel lines, the pre-image and image, I should say the final image, are parallel. So if we go back to that picture that we just did a little bit ago, Km and K double prime, M double prime are parallel. If we find our slopes, these slopes are pretty easy. It's -1, okay, up 1, over 1 to the left for each of those. They have the exact same slope, so they are parallel. Now, we don't typically say shapes are parallel, because like I could have had, I'll say this is N. All right, if I had flipped that over, that would have been 1. It'd be right below K each time, right? So this would have been N double prime. I'm going to erase that in a second, so don't even worry about writing that in. Kn and K double prime N double prime would be parallel. Nm and N double prime M double prime would be parallel. All right. That last one, saying they're parallel, isn't the greatest because technically speaking, those are the identical line. They're the same line because of how they are on the graph. They're perfectly horizontal at the same y value. But each piece would be parallel. Each piece would have the same slope is basically what that gets down to. So, like I said, I'm going to erase these real quick. All right. Okay, now another thing, if we are doing that same double reflection, so in a double reflection, over parallel lines, the distance between the pre-image and image, again I'm talking about the final image, that double prime piece, is twice the distance between the parallel lines. Now again, I'm going to go back to that same picture again, just to kind of show what this represents. If you feel like you need to look at that screen a little bit longer, go ahead, pause. But if I count the distance, I'm going to count because I gave nice parallel lines that are vertical, so I can just count. I could use my distance formula. But the distance from line M to line N, from 2 to 5, that is a distance of 3. Well, the distance from K to K prime, or K double prime I should say, should then be 6. Well, 1, 2, 3, 4, 5, 6. Same with M. 1, 2, 3, 4, 5, 6. That's going to work for all of those if we're doing a double reflection. Notice it's not true for a single reflection. But it's with a single reflection, you don't really have that second line, so this would basically become useless in that case. All right, and there's one more that you probably did notice for this one. A double reflection. Over parallel lines. Can be duplicated with a translation. Okay, if you flip something all the way over and so it's facing the same direction it started, you could have just pushed it over to begin with. Is basically all that's saying. All right, so we've got a diagram where it looks very, very complicated. We just reflected segment HG over line K to get A prime G prime. We reflected A prime H prime G prime over line M to get H double prime G double prime. And then to make the picture confusing, we just connected all the dots. Okay, so that's what we're looking at. So in the diagram below, that's what happened. And then HB is 9, and then DH double prime is 4. We want to find all these different pieces. Well, HG is going to be congruent to H prime G prime and also to H double prime G double prime because this is an isometric transformation. Remember, when we're saying things are congruent, we have to have that line segment symbol above. Otherwise, we're talking about a number, and a number can't be congruent to anything, so make sure you have your notation correct. All right, now it says HB, segment HB is congruent to what? Well, anytime you are reflecting across, you are going to end up with the same distance away. So HB is the same as H prime B. They're the same distance away from each other. All right. There could be a circumstance where this could be congruent to H prime D or H double prime D, but you're not guaranteed that, and in this case, they would not be congruent. So for GA, segment GA, I would want segment G prime A. And now for this next one, it says G double prime. That's a length. It says, what is the length? Well, it's the same length as H double prime. So from here to there is the same as from there to there, because we're doing a double reflection over those parallel lines. We're making a parallelogram is all that's happening. I can actually find this number because, like I already labeled this 9 to 4, this has to be a 9, and then this has to be a 4 because these two pieces are congruent, and those two pieces are congruent. So 9 plus 9 is 18, plus 4 is 22, plus 4 is 26 units, whatever, inches, miles, whatever. Then it says, does AC equal BD? Yes. Yes, it does. Could I figure that out? Absolutely. BD at 9 plus 4 is 13. I would not have been able to do this piece or this piece if it had not been for the fact that K and M are parallel lines. If those arrows were not there, indicating that they are parallel, I would be able to say HB and the GA. I'd be able to do those parts where it's just, hey, you reflect it, you're a certain distance away. But that double reflection, we won't be able to identify exactly how far away things are because, or we won't be able to identify if these are the exact same distance or if these are equal because we wouldn't have parallel lines. So those parallel lines are important. If it doesn't tell you that they are parallel, but it tells you angle information, like we have a right angle and a right angle, you can use your parallel lines cut by a transversal type theorems where it says if lines are cut by a transversal and we have corresponding angles congruent, those lines are parallel. Those rules still apply. All right, and then this is probably my favorite piece from this entire chapter. If we are reflecting over lines that do intersect. So parallel, we knew that they were twice as far away as the lines were from each other, and we know that we have parallel stuff. If we reflect over line M and then line M, okay, I'm going to try to sketch this out as best as I can. Since we're doing a reflection over a line, not on a grid, it's not going to be perfect, but we'll do what we can. I always like to start with my closest thing first, so C is pretty close, so I'm going to put C prime right there. D would then have to be like right there, so that's D prime. B is closer than A, so I'd go B prime right there, and then A prime would be right there-ish. Obviously not a perfectly drawn rectangle, but they're supposed to be isometric. Well, then I would do that again. D prime would go to here to become D double prime, and C prime would come down here to become C double prime. Then I would have A double prime and B double prime. All right, so this is the cool part. If we are reflecting over two intersecting lines, okay, this can be duplicated by a rotation of twice the angle measurement. Oops. Between the lines. So what I could say is that this was actually just going to be a rotation of 90 degrees, and then I would have to specify direction clockwise about, and then I'll give this point a name. We'll say point Z. All right, now I got that 90 by taking twice of that 45 degrees. We should be able to recognize that this is 135 degrees because they are a linear pair. So I could give you the same picture, say this is 135 degrees, not tell you that's 45, and ask you to tell me a rotation that would have also worked to get from our pre-image to our image. And you have to figure out that that's 45 degrees, and twice 45 is 90. I can give you these problems where this is not a nice number. I could say that that is 37.2 degrees. You would just take 37.2 times 2. So it's a rotation of that amount. But then you have to pick up the direction. So make sure you know clockwise and counterclockwise. If I'm starting here to get to here, that would be clockwise. If I was starting here to get back here, that would be counterclockwise. All right, so here's a spot for you to write a summary of what we talked about today and any questions you may have. Make sure you're working on your homework, and hope everybody has a great day.